Hello, I am going to be teaching you to do these problems for nursing using dimensional analysis. So, problem number 1, you are administering triple antibiotics to an 8-year-old child who had surgery for a ruptured appendix. The client weighs 46.2 pounds. The usual dosing for the 3 antibiotics is as follows. So, we'll start with A. Your client's AMP dose is ordered to be administered every 4 hours. So I'm going to circle that because if we are administering every 4 hours, we know that 24 divided by 4 is 6 doses. And I'll show you why that's important in a moment. Okay, so let's start with the low end of the dosage range. So with weight-based problems, we start with the weight that we have. So 46.2 pounds is where we'll start. And we know that we have 2.2 pounds per kilogram. And on the low end, 200 milligrams per kilogram. And then everything's balanced out. All right. And then you put that in the calculator. You get 9240 divided by 2.2 is 4,200. And then we're going to take this 4,200 because that would be per day. But we want per dose. So we're going to divide this by 6. And that will give us 700 milligrams. So that is our low end of safety per dose. Okay, so doing the same thing for the high end, starting with the weight we know, 2.2 pounds kilogram, 400 milligrams per kilogram. It's 18,480 divided by 2.2 is 8,400. And then we're going to divide by the 6 doses again. And that will give us 1,400 milligrams. Okay. Pop that right up there. And then that gives us our safe range for this client is 700 to 1,400 milligrams per dose. All right, so B. The safe dosing range of the Ceph for this client is, all right, so 100 to 150 milligrams per kilogram per day every 8 hours. So we know that 24 divided by 8 is 3 doses. Okay. Weight-based problem. 46.2 pounds. 2.2 pounds per kilogram. And then 100 milligrams per kilogram for the low end. I guess it's 4620 divided by 2.2. Is 2,100. Divide that by the 3 doses. And we get 700 milligrams for the low end. And then we will do the high end, the 46.2 pounds. 2.2 pounds per kilogram. 150 milligrams per kilogram is 6,930 divided by 2.2 is 3,150. Divided that by the 3 doses is 1,050 milligrams per dose. So our safe dosing range of the Ceph for this client is 700 to 1,050 milligrams per dose. Okay, so now C for the MET. So for that one, we'll scroll back up, 30 milligrams per kilogram per day every 6 hours. So we'll do this again. 24 divided by 6 is 4 doses that we are giving in one day. All right, so weight-based, 46.2 pounds, 2.2 pounds per kilogram, 30 milligrams per kilogram is 1386 divided by 2.2 is 630. Divide that into 4 doses and you get 157.5 milligrams per dose. So you pop that right up there. And you see how when you're doing these problems, things have to match up to balance out the problem. So pound to pound, kilogram to kilogram. And this right here, you want this to be what your answer is going to be. So if we want a milligram, we need to have a milligram here. If we were looking for milliliters, this would be milliliters right here. Okay. So moving on to problem 2. Doctor orders Zithromax for a child that weighs 64 pounds. The safe dosage range for this medication is 10 to 12 milligrams per kilogram per day. Okay, so this is actually a little bit easier because we're not doing it per dose. Pardon me. Okay, so starting with the weight, 64 pounds, 2.2 pounds per kilogram. Then we'll do the low end, 10 milligrams per kilogram. Okay, and that gives us 640 divided by 2.2 is 290.9. And then we will do the high end, 64 pounds, 2.2 pounds per kilogram, 12 milligrams per kilogram. And that gives us 768 divided by that 2.2 is 349.1. So that is our range right there, 290.9 to 349.1 milligrams. So if the doctor orders 300 milligrams per day, would this be a safe dose to give? Well, if we can give 290 to almost 350 and it's safe, then yes, that is a safe dose. All right, moving on to question 3. A 14-year-old adolescent boy who weighs 193.6 pounds, post-op day 1, receiving IV Zosyn, 3,000 milligrams every 8 hours. A safe dose for Zosyn is 240 to 400 milligrams per kilogram per day. Okay, so first for A, we're going to find the safe dose range per day. Okay, so starting with the weight, 193.6 pounds, 2.2 pounds per kilogram, and then on the low end, 240 milligrams per kilogram. That gives us 46,464 over 2.2, which gives us 21,120 for our first answer, because it's just asking us per day, not by the dose. Okay, and then for the high end, 193.6 pounds. Oops, there we go. 2.2 pounds per kilogram, 400 milligrams per kilogram. Gives us 77,440 divided by 2.2. And that is 35,200. So we'll just plug that in right there. And that is our answer for the safe dose range per day. Now per dose. So we know if we're giving it every 8 hours, 24 divided by 8 is 3. So we will just take those that we had, the 21,120 and divide that by 3 to give us the 740. And then we will take the 200 divided by 3 to give us 11,733.3 milligrams per dose. Okay, so is the order the provider wrote a safe dose? So let's take a look. He wrote 3,000 milligrams every 8 hours. Well, I think we already know, just by looking, that per dose we need at least 7,000 milligrams. And then if you do the daily total of 3 doses of 3,000 milligrams, you would get the 9,000 milligrams. And that still wouldn't be anywhere near this daily minimum. So no, this is not a safe dosage, pardon me. Because if we are not administering enough medication, we are not treating the underlying infection or illness. So it is not safe. Okay, moving on to question 4. A child weighs 20 pounds. The doctor orders Augmentin 150 milligrams by mouth every 8 hours. Information from the drug guide states that children less than 40 kilograms receive 6.7 to 13.3 milligrams per kilogram every 8 hours. The medication comes Augmentin 125 milligrams per 5 mLs. What is the safe dose range per dose? Okay. So we know that we're going to give it every 8 hours. So we'll start 24 divided by 8 equals 3. So we know we're giving 3 doses. And then we will go here, 20 pounds, 2.2 pounds, and 1 kilogram. Then the low end, 6.5 milligrams per kilogram. And that'll give us 134 divided by 2.2 equals 60.9. And we'll divide that by 3 doses to give us 20.3 for our low end. And then again, 20 pounds, 2.2 pounds per kilogram, 13.3 milligrams per kilogram. And that'll give us 266 divided by 2.2 is 120.9 divided by 3 gives us 40.3. So just like before, we get to our total and then we divide by the doses and there we are. Okay, so is this ordered dose in the safe range? So let's take a look here. All right, so if he's ordering 150 milligrams per dose, we already know that is way above the safe range here because this child can only receive up to 40.3 milligrams. So no, that's not safe. That's too much. Okay, moving on to question 5. The physician's order is Lasix 15 milligrams by mouth twice a day. The medication comes furosemide or Lasix 10 milligrams per ml. How many mLs would you need to draw up to equal 15 milligrams? Okay, so you could probably do this in your head, but if not, I'm going to show you how you can do it using dimensional analysis. So you know that you need 15 milligrams. So you start with the order. And you know that you need to end up with mLs. And then you need to balance this out, 10 milligrams on the bottom. So then you're just going to do the 15 divided by 10. They give you 1.5 mLs. So if you're ever struggling, or you're like me and you're taking an exam and you have to use your calculator to do 1 + 1 because you just don't trust yourself, there you go. Use the formula, double check. All right, moving on to B. The doctor's order, Augmentin oral suspension 300 milligram by mouth 3 times a day, available as 125 milligrams per 5 mLs. How many mLs will the nurse administer for 1 dose? Okay, so we'll set that up here. Our order is for 300 milligrams. We want to know mLs. We have 5 in 125 milligrams, balancing it out. 300 times 5 is 1,500, divided by 125 equals 12. So we will do 12 mLs. All right. Moving on to 6. The MD writes an order for Lortab elixir 10 milligrams by mouth as needed for pain every 4 hours. The pharmacy dispenses you with 7.5 milligrams per 15 mLs. How many mLs will you administer per dose? Okay, so the order, 10 milligrams. We want to know mLs. We have 15 mLs. Balance it out, 7.5 milligrams. 10 times 15 is 150, divided by the 7.5 gives us 20 mLs per dose. Okay. Moving on. Problem 7. The order is for Gent, 80 milligrams IV piggyback in 100 mLs every 8 hours to run over 60 minutes. Calculate the drip rate in drops per minute. The tubing delivers 20 drops per ml. Okay, so we know we want minutes here. So we're going to put minutes here. That's our order, essentially. Okay, so that we know we have 60 minutes. We want to run 50 mLs over those 60 minutes. And then we know we have mLs to match our mLs here. And then we know getting ahead of myself. My apologies. 100, not 50. And there we go. mLs to mLs, and then we know that we have 20 drops per ml. And now we're ready. So we got 2,000 there, and then 60 on the bottom. And that gives us 33 drops per minute. And that is our answer. Hope that was clear. You start with the minutes as the placeholder, and then you know that you have 60 minutes, and then you're running this 100 mLs over 60 minutes. You need to balance out your problem with the mLs, and then to match your mLs, it's married to this drops right here. Okay, problem 8. The order for Gent 100 milligrams IV piggyback and 50 mLs every 12 hours to run over 60 minutes. Calculate the drip rate in drops per minute. The tubing delivers 15 drops per minute, or drops per ml. Round to the nearest whole number. Okay, so again, I like to put the minute there for a placeholder. And then I know that I have 60 minutes. And I want to run 50 mLs in those 60 minutes. I know that I need mLs to balance, and that I have 15 drops per ml. So now we're ready to calculate it because I want my answer to be this. Okay, so that gives us 750 divided by 60 is 12.5, but we are going to round that up to the nearest whole number, and that will give us 13 drops per minute. All right, and that is all she wrote. I hope this helps you out.